You've been told your whole life that the world around you is made of solid things. But it's not exactly true. In fact, nothing you can touch is solid in the way you imagine. So why does everything feel solid? Let's start with something simple. You place your hand on a table. It feels firm, stable, real. It seems like your hand is directly touching the surface. But here's a strange question. What does touching actually mean? It feels obvious. Of course your hand is touching the table. But when we zoom in, the story changes. Closer and closer and closer until we reach atoms. Everything around you, your hand, the table, the air, is made of atoms. And atoms are incredibly small. At the center, there's a nucleus. Around it, electrons. But here's the surprising part. If an atom were the size of a football stadium, the nucleus would be like a tiny grain of sand at the center. And the electrons, they wouldn't be little balls orbiting like planets. They exist as a kind of cloud, a region where they're likely to be found, which means most of the atom is empty space. Not a little empty, almost entirely empty. So when your hand meets the table, it's not solid blocks colliding. It's mostly empty space, interacting with more empty space. That sounds impossible. So why don't you pass straight through the table? Why doesn't your hand just go right through it? Here's where it gets interesting. The answer isn't solidity, it's interaction. More specifically, electromagnetic forces. Electrons carry negative charge, and when the electrons in your hand get very close to the electrons in the table, they strongly repel each other. They resist being pushed into the same region. So, as your hand approaches the table, these tiny repulsions build up extremely quickly. And what you feel as solid is that resistance, not hard contact, but a powerful push between charged particles. Now pause for a moment. You're not touching the table in the way you imagine. What you experience as touch is the electromagnetic force pushing back against your hand. But here's where it gets even more subtle. There's another effect at play. At the quantum level, particles like electrons follow a strict rule. They cannot occupy the same quantum state in the same place. You don't need the name. Just think of it like this. Nature doesn't allow them to fully overlap. So when you push atoms closer and closer together, you're not just fighting electric repulsion. You're also running into this built-in limit. Together, these effects create what we experience as solidity, but it's not solid in the everyday sense. Now think about this. If atoms are mostly empty space, why does everything look continuous? Why does it feel smooth and solid? The answer is scale. At your level, these interactions happen so quickly and in such huge numbers that everything blends together, like a movie made of individual frames. You don't see the gaps. You see a continuous picture. In the same way, countless tiny interactions create the appearance of solidity. Now imagine something. You shrink yourself down, smaller and smaller, until you're the size of an atom. What would the world look like? Not solid surfaces, but vast empty regions, with tiny, dense nuclei and spread out electron clouds. The table wouldn't look like a flat surface anymore. It would look like a loose structure, mostly empty, held together by forces. And your hand? Exactly the same. Now imagine trying to touch the table at that scale. You wouldn't collide like solid objects. You'd experience strong repulsion, like trying to push two identical poles of magnets together. They never truly meet. They resist. Now let's step back. Everything you've ever touched, every object you've held, every step you've taken, has been governed by these invisible interactions, not solid contact, but forces acting across tiny distances. Now here's the deeper idea. If solidity comes from interactions, then matter itself isn't made of hard, solid pieces. At a deeper level, it's made of patterns of energy and fields, stable arrangements that behave in consistent ways. That's what gives rise to the solid world you experience. So when you press your hand against the table, it feels real. And in everyday life, it is. But underneath that feeling, there's a completely different picture. A world where empty space dominates, where particles don't behave like tiny solid balls, and where what you feel is not contact, but resistance. So the next time you touch something, pause for a moment. What you're experiencing is not solid matter pressing together. It's the result of invisible forces and fundamental rules, preventing things from occupying the same place. And maybe the most surprising part of all is that a universe made mostly of empty space can feel so completely solid.